I remember a meeting during this fall. So there was with a colleague of mine working as a controller, and she's requesting me to do updates in a report she's using. And she's looking at me very tensely in the eyes. I can really feel her eyes. And it's like, we're on a Teams meeting, it's over a screen. And she says, "Are you telling me I cannot have this report in Excel?" And I try to calm the situation, talk slowly, peacefully. It's not that I'm trying to take something away from you that you use. I'm trying to build something with you that you can use even more and even better. Something that you can share easily and make even more decisions from. My name is Karin Madsen. I work as a data analyst at ICA. And we're going to talk today about data at ICA, a treasure hunt in a maze of challenges.
And my name is Anna Bäcklund, and I lead a great data science team at ICA with men and women of different backgrounds and ages, and we drive the AI initiatives across the company. That means that I normally get to answer questions such as, how should we work with AI at ICA? What are the best practices in machine learning? Or what kind of tools should we use? We will talk about working with analytics at ICA today, but let's start with a short overview of what we will go through. So we'll start by telling you about the data that we have at ICA, followed by a short Corona-themed quiz. Thereafter, we will discuss how Corona has affected the data, which in turn has affected the analysis we can do. And thereafter, we'll tell you about how it is to work with AI and analytics and some of the challenges it might bring, as well as how we handle these challenges. We hope that there will be something of interest for all of you listening today. For those of you who are working in analytics, we hope that by listening to us describing our challenges and how we handle them, you might get some help if you encounter similar challenges at your companies. And for those of you who are not working in analytics, we hope that you will learn something new about this very exciting field today. But before deep diving into the data, let's have a short check-in on menti.com.
Yes, so pick up your phone or your web browser and enter menti.com. Use the code 65091421, as you should see on your screen. And we're very sorry that we cannot meet you in person. But we want to know a bit more about you and connect a bit. And we want to know, do you work with analytics today? So here we have a broad selection of answers. It's either yes or no, but I would love to learn more. And feel free to interpret work with analytics as you like. Okay, so we have some people working with analytics and some people that want to learn more. It's kind of a even mix here. So nice to see. Okay. We can move on a bit. I don't know if this question is a bit trickier, but what is your current role? Do we have any data scientists? Do we have any data analysts or anything else we can come up with? Let's see. Ooh, it's a very broad mix of people. I love this. So we have some students, consultant, data analysts.
Where's the data scientists?
Where are they? Okay, maybe we can convince them to go towards that area. Thank you all for connecting with us a bit. I'm going to start talking a bit about ICA's data. So that is what we call the treasure. I personally visit ICA maybe 3 times a week, every day when it's not Corona. And walking in the store, others might see pasta, carrots, frozen peas, but I see data everywhere. So we have all the goods generate data coming through the store. With what frequency, how much is delivered, where does it come from? There's information about what kind of assortment a store could have, how everything should be placed, and how much space it needs. We have prices everywhere. A single item can have different prices in every store, since the store owners set their own prices on all items. We also need to consider what prices does the competitors have. And we have the grand finale, the receipt. How much did I spend in the store? What did I buy? What items were bought together? And did I use the self-scanner or the self-checkout or the cash desk? These are some data connected to the physical store. We also have all the online touch points. So when the customer plan what to shop, search for recipes, and they make the whole purchase online, and they can get it delivered at home or pick it up at the store. And this is just some data connected to the grocery shopping we're all involved in. ICA stands for Inköpscentralernas aktiebolag. It's a purchasing central. So making sure our stores can buy wholesales at the best price is kind of ICA's core business. And on top of that, ICA grocery retail is just one part of ICA Group. So apart from ICA groceries in ICA Group, we have Apoteket Hjärtat, the pharmacy, Rimi Baltics, which is groceries in Baltikum, ICA real estate, and ICA Bank. And what does that tell us? Even more data. But why do we need all this data, and why is it our treasure? For me personally, it's a treasure working with data that is so closely connected to everyday life. As I said, I do grocery shopping all the time, and then eat food all the time as well. And ICA's vision is to make every day a little easier. And that's what me and Anna try to do all the time as well. So we have all these complex data flows, advanced analytical models, and we try to use them to make our customers and our co-workers' life a little easier. And we promised we were going to get back to Menti, which we will now. We're going to look at some charts from the previous years. We'll call it a Corona quiz. And we'll see if you can guess what product is hiding behind the chart. So, if you're hopefully still in Menti, what product had a huge peak in sales in March 2020 compared to last year? Is it chocolate, toilet paper, or soap? We're looking for something that everyone wanted in March. Anna, did you want it?
Yes, I have to admit that I'm guilty of buying slightly more than I actually needed.
You're not the only one. And I think our friends here have figured out that the correct answer is toilet paper. So I think we're all guilty there. Some of you thought it was chocolate, and I think we can both relate to that.
Yes, we can.
We bought some extra chocolate as well. Now we're looking for a product that has sold at a constant higher level from March 2020 and onwards. So we've been around 20% above compared to last year. Is it coffee, crisps, or yeast?
And this can have something to do with working from home.
Yes, and when we work from home, we sit on the couch and eat crisps. No. We drink coffee. At least I do.
How many cups of coffee do you drink nowadays, Karin?
2 or 3, that's okay.
That's perfectly fine.
That's perfectly fine. Okay, now we're gonna look at another chart. We're looking at the sales development compared to last year. And we're searching for a product that has sold much more during this winter compared to last winter. Is it charcoal, meatballs, or chocolate? We have this chocolate, we really like that,
yeah, we do.
to put it in. But is it chocolate that's been around 150% above the past few months here?
And this product is usually connected to the summer months, at least in Sweden.
Yeah, this is a bit trickier. It is actually the correct answer is the charcoal. I don't know about you, but I've been doing a lot of barbecuing this winter to be able to spend time with friends and family afterwards. But I'm so impressed by all this, by your guesses. Great work. But as we could see, the data has been pretty much behaving in ways we couldn't really expect. Can we handle this in any way when doing analysis with data?
Yes, we can. There are some ways. Now, as you all are aware of, corona is a massive public health problem that has affected all of our lives in many different ways. The chaos and uncertainty surrounding the coronavirus pandemic have also claimed another victim, namely the machine learning models that are programmed to make sense of our behavior. When corona hit, people started buying things in ways they never done before. The shift was quite sudden, and the ripple effects have been seen across the retail supply chains. And this has created problems for the models that run behind the scenes in inventory management, recommendation engines, forecasting, fraud detection, marketing, and many other fields. The machine learning models that are programmed and trained on normal human behavior are now finding that normal has changed. And while the models are built to take in new data, they perform badly when the input data differs too much from the data they were trained on. Furthermore, the models are typically not so robust that they can adapt fast enough to sudden changes in the underlying data. And just as you saw in the quiz, ICA's data has indeed been affected. So what kind of impact has this then on our models? Well, a very common model in retail is the recommendation engine. Most of you might already know how they work, but to give a short recap, a recommender system is a model that recommends relevant items to the users, and this might be products to buy, or movies to watch, or songs to listen to. One of the most common methods to build a recommender system is to use collaborative filtering methods. Collaborative filtering methods are based on past interactions between users and items that are recorded in order to produce new recommendations. So, if we have a fixed system with some items such as toilet paper and coffee, the more the users interact with the items, the more effective this system will be and the more accurate the recommendations will be. But suppose that we want to add a new item or a new user. So there are ways of handling that. One way would be with a random strategy, where the model would suggest a random item to the new user or a new item to a random user. We might also use a maximum expectation strategy, where the model would suggest a popular item to a new user. So suppose that this is our fixed system, Karin is the user, these are the items, and the model would then say to me, as the new user, you know what, Anna? We know that our users like to drink coffee. Maybe you would like to buy some coffee. And I would say, no thanks, I'm a tea drinker. Thanks anyways. If there is a change in the underlying data, this will also make the recommendations less accurate. You might, for instance, get offers for toilet paper, even though you probably don't use that much of it. Another model that is also affected by the corona change in our data is time series prediction. Suppose that we want to predict electricity consumption or the trend in financial markets or the amount of toilet paper ICA will sell. Or we might want to forecast at what time of the year there is going to be a peak consumption in meatballs so that we can adjust the supply in the stores. then we look to time series prediction. Now, a time series is a sequence of data points ordered in time, and we want to forecast future values of it that might correspond to sales patterns or demand and supply patterns. In order to do so, we have to analyze the time series. We can break it down into different parts, a so-called time series decomposition, to identify patterns such as a trend or seasonality or noise. The trend corresponds to the long-term pattern of the time series, and this is often linearly increasing or decreasing. The seasonality corresponds to repeating patterns or cycles of behavior over time, often connected to calendar events. And this is something we have a lot of in ICA's data. Think of all the Swedish holidays and the food we like to eat during them. And then we have the noise, which is a variability in the observations that the model can't explain. And this is also referred to as the residual or the error. Now, we probably want to do some kind of data cleaning. We want to do some careful consideration of the outliers. There might be some frequency worth looking into, and probably some kind of data transformation before getting to the fun part, the actual prediction. There are different ways we can do the prediction. One of the most classical methods is the moving average model, which is a linear combination of past error terms, and this is often used if you want to model univariate time series. In the moving average model, we can conceptually think of a linear regression, which corresponds to the current value of the time series against the current and previous error terms. If we know how far off our estimation yesterday was compared to the actual value, we can then tweak the model to make it even better. And sometimes this classical method is good enough, but other times we might want to go with a slightly more complicated method, such as recurrent neural networks. Now, recurrent neural networks are networks that can process a sequence of inputs and retain its state while processing the next sequence of inputs. This can be compared to traditional neural networks that process an input and moves on to the next one, disregarding the order. But time series data has a specific sequence of data points that are ordered, and this order has to be followed in order to be understood. What does this mean, you might ask? Then think of the alphabet. Everyone knows the alphabet. You have A, followed by B, followed by C, and so on. Now try to say the alphabet backwards. In Swedish, the last letter is Ö, so then it will be Ö, followed by Ä, followed by Å, followed by Z, and so on. This is much more difficult, isn't it? And the reason for that is because you have learned the alphabet as a sequence. And sequential memory is a mechanism that makes it easier for the brain to recognize and learn sequential patterns. And recurrent neural networks have this sequential memory concept, which means that they are very useful to time series data, since they can remember all the previous data points while searching and finding developing patterns in the data. Then, of course, recurrent neural networks can't help us with everything. They have the vanishing gradient problem and are usually not very good for long-term planning. This can partly be solved by changing the activation function from sigmoid to ReLU and so on, but it still doesn't take away the fundamental problem we are experiencing right now. We have a pandemic that is changing our behavior, and the models are trying to forecast future value without having a normal baseline to connect to. This is where we need expert human intervention. We need a team that can connect what's going on out there in the world and in the markets to what's going on here in our models. And this takes us to the next part, where we will talk about how it is to work with analytics at ICA.
Yes. So working with analytics at ICA, analytics is a centralized function. So we are around 30 colleagues working with data and analytics. There's the team of data analysts, where I belong, and we have a team of data scientists, Anna's team. We also have business analysts and business translators. And this is great for building and sharing knowledge within our area. But I mean, we like to use our data. I mean, we can do quizzes with it, but it doesn't really give you any value until the business operation starts using it. And since we're centralized, we do get further away from the business. So in order to get this value from data, besides from doing quiz, we need to teach the business operation how data can be used, how models work, and they need to teach us what are their everyday issues and struggles, what do they need data for, what do they need for making great decisions. So this constant exchange between business operation and analytics is something we work with every day to improve. Another challenge is that everyone at the business are at different analytical levels. Someone might use data every day, and they know why it looks like it does, how its data behaves. So trying to implement an advanced model, as Anna is talking about, there could be pretty easy. They have someone that can help to do this connection. What is happening in my area? What is happening in the model? But at another place of the business, just making sure that they can access their top 5 KPIs and that they can track them and know what impacts them, that's their start. So always trying to meet the business where they are right now is a challenge for us that we work with. Do we have any other challenges, technical challenges?
Unfortunately, we do. So apart from the organizational challenges that Karin just described, there are also some technical challenges. Normally, at large companies, you have the traditional platform, the on-premises, where all the software and infrastructure is stored in-house. And this might be preferable if you have sensitive data that you don't want spread out across servers across the globe, or if you want or need to have a complete control over your whole solution. And then you also have cloud computing, which refers to computing services via the internet. Now, there is this running joke that cloud is just another word for somebody else's computer, but the key characteristic is that you pay for what you use, and that the cloud service provider maintains the network architecture so that you can focus on the analysis and the applications that you build. This alternative might, however, be very expensive if you write suboptimal queries, or if you have a network where you need to transfer the data stored at different servers between the servers every time you do a computation, so please check for that. This is an ongoing journey at ICA, where we are transitioning from the traditional on-prem to the cloud, which is very exciting. And then, of course, we have the never-ending question, how to get to the data, where to find the data, or where to find people that can explain the data, how to learn enough that you become one of these persons, how to understand how we can model the data in different ways. And I'm going to end this session with the way that we are trying to meet these challenges, which is having the right team. Having the right team to make data accessible, having the right team to understand the data and to model it, having the right team to teach the business operations about how to use analytics, having the right team to connect what's going on out there in the market to what's going on here in the models. And this is something we are trying to build at ICA, and this is what we will end this session with. Thank you so much for listening today.
Thank you.